development of Iran's nuclear program is one of the most complex and controversial national engineering projects in modern history. For Tehran, nuclear capability is not merely a symbol of technical prestige, but an instrument of sovereign determination born from deep security trauma. This infrastructure has not emerged in a vacuum. It is a direct response to sustained military pressure from the United States and Israel. Through doctrines of passive defense and technological self-reliance, Iran has constructed a nuclear ecosystem designed to withstand kinetic devastation. Following Israel's 1981 airstrike on Iraq's ARAK reactor, Iran recognized that above-ground nuclear facilities are highly vulnerable targets. Consequently, its primary strategy has been to relocate strategic assets deep underground. The FORDOW Fuel Enrichment Plant, FFEP, is a physical manifestation of Iran's justified security paranoia. Built beneath a rocky mountain near the holy city of Qom, the facility represents an extraordinary feat of military-grade civil engineering. Located approximately 80 to 90 meters beneath solid granite layers, FORDOW is designed to remain operational even after being struck by the United States' most powerful bunker-busting bomb, the Massive Ordnance Penetrator, MOP, GBU-57. Technically, FORDOW is far more than a simple underground chamber. It is a labyrinth equipped with advanced air filtration systems, independent backup power generation, and protection against electromagnetic pulse, EMP, attacks. With a capacity of nearly 3,000 centrifuges, it serves as a strategic fallback should the main facility at NATANZ be destroyed. The construction of FORDOW sends a clear technical message to the world. Iran's enrichment capability cannot be eliminated by air power alone. NATANZ is the heart of Iran's enrichment program. Despite repeated sabotage efforts, from the Stuxnet virus to physical explosions in 2020 and 2021, Iran has demonstrated a remarkable ability to rebuild. After each attack, Iran has not only repaired damage, but also constructed new, significantly deeper underground facilities within the same area. Satellite imagery analysis indicates the excavation of large new tunnel systems capable of housing advanced centrifuge production lines, ensuring that the brain of Iran's enrichment program remains beyond the reach of cruise missiles. A central pillar of Iran's nuclear development is its self-sufficiency in centrifuge manufacturing. These machines are critical as they separate uranium-235 from uranium-238 through ultra-high-speed rotation, ultra-centrifugation. Centrifuge Generation Leap. Iran began with the IR-1 model, a reverse-engineered version of the outdated and failure-prone P-1 design. However, international sanctions forced Iran to innovate domestically. IR-2 meters and IR-4 transition from aluminum to carbon fiber and miraging steel, enabling higher rotational speeds without mechanical failure due to resonance or overheating. IR-6 and IR-9 represent the peak of Iran's technical achievements. The IR-6 is reportedly 10 times more efficient than the IR-1, while the IR-9, still under development, is projected to be up to 50 times more capable. Evidence suggests Iran has mastered precision welding and advanced magnetic bearing systems, essential for machines that must spin tens of thousands of times per second continuously for years. Domestic production allows damaged units to be replaced within days rather than months. Enrichment levels. Iran's decision to enrich uranium to 60% purity marks a significant technical milestone. Uranium enrichment is not a linear process. Reaching 60% from natural uranium 0.7%, requires roughly 90% of the total separative work units, SWU, needed to achieve weapons-grade levels, 90%. In other words, Iran has already passed the most difficult stage in terms of infrastructure and knowledge. Maintaining stable enrichment at this level demonstrates that its automated control systems and UF6 gas flow management meet global technical standards. A nuclear program is only as strong as its supply chain. Iran has built a fully domestic nuclear fuel cycle within its sovereign territory. Although Iran's uranium reserves are not among the largest globally, mines in Sagand, Yazd, and Gachin, Bandar Abbas, ensure a steady supply of raw material that cannot be embargoed. The yellowcake processing plant in Ardakan completes upstream independence. The Uranium Conversion Facility, UCF, in Isfahan converts yellowcake into uranium hexafluoride, UF6 gas, a highly corrosive and dangerous chemical process. Failure at this stage would cripple the entire enrichment chain. Iran has mastered high-purity UF6 production, crucial for preventing damage to sensitive centrifuge components. Iran's ability to manufacture its own fuel rods for the Bushehr power reactor demonstrates mastery of nuclear metallurgy. This involves converting enriched uranium into solid oxide and encasing it in zirconium alloy cladding, a process requiring microscopic precision to prevent radiation leakage. The construction of the heavy water reactor in Kondab, ARAK, adds another critical dimension. Unlike the light water reactor at Bushehr, which uses enriched uranium, heavy water reactors can operate on natural uranium. Technically designed for producing radioisotopes for medical and industrial use, this reactor also represents strategic diversification. Mastery of heavy water technology provides Iran with an alternative nuclear pathway not solely dependent on uranium enrichment. Iran's most valuable nuclear asset is not concrete or machinery, but its thousands of domestically trained scientists and engineers. In response to the assassination of nuclear scientists, Iran adopted a strategy of knowledge, decentralization, through institutions such as Sharif University of Technology and Encirclement University. Nuclear curricula have become integral to advanced engineering education. Iran no longer depends on a few key figures. Knowledge of building, operating, and repairing nuclear installations is distributed among thousands of young technicians, creating what can be termed intellectual resilience. When cyber or physical attacks occur, rapid response teams can diagnose and repair systems using locally produced components and software. Reverse engineering sabotage technologies has become a distinctive capability of Iran's nuclear industry. Iran's nuclear development is inseparable from the conventional military infrastructure protecting it. The country applies a rigorous passive defense doctrine, integrated air defense systems. Nuclear facilities are shielded by layered defenses, including long-range systems such as the Russian S-300 and the domestically developed Bavar 373, as well as short-range missiles and anti-aircraft artillery. Following the Stuxnet attack, Iran established a dedicated cyber command to protect nuclear industrial networks, including isolated intranet systems disconnected from the global internet. Camouflage and deception, decoy facilities, and system redundancies ensure that potential attackers can never be fully certain of the true primary targets. After decades of pressure, sabotage, and sanctions, Iran has successfully built a resilient and self-sufficient nuclear infrastructure. Objectively, it has reached the status of nuclear hedging, or a latent nuclear power. This means Iran possesses all the essential components: underground infrastructure, advanced enrichment machines, a complete domestic fuel cycle, and a robust human knowledge base to become a nuclear-armed state in a short time frame, should a political decision be made. This achievement is not the result of massive external assistance, but rather adaptive innovation under sustained external hostility. By placing nuclear technology at the core of its national defense identity, Iran has ensured that its nuclear program is not merely an energy project, but a fortress of sovereignty built upon an unshakable foundation of technological independence. This strategy of building under pressure has made Iran's nuclear program one of the most difficult infrastructures to permanently disable through conventional military means.